everyone, my name is Sean Kennedy, and this time now I'm going to do volcanoes. Well, I already did that last time, I did 2 episodes, so that makes sense. I'm going to do erosion. I'm going to do this for my class, also for you guys, so let's start with this. First photo, I actually tried slideshow, I don't know how it works, so that's why I'm not going to try it. Let's start with water erosion. Deposition and movement of sediment. If I can draw this, basically, I can't. There. Basically, what they're saying is, the pink is fast-moving water, the purple is slow-moving water. Basically, they had to make a line that's straight into a curve. Because most rivers you see has curves in it. So, basically, how does that work? First, as the water is moving, well, something has to make sure to make the bank, make the water flow. Well, basically anything that can drive water. Well, anything that's, yeah, I'm gonna have to rehearse my lines. Okay, so basically, if like a rat or anything that can make underground homes, like any animal that makes underground homes and banks of rivers, digs a hole right here and makes a nice cozy home. Over time, water will start hitting the side. Basically, let's say the den is right here. So technically what would happen over time is that the water would keep hitting against the side. So water will move this way. Okay, I got it. Basically, if the den was right here, water, as it does, will try to go into that hole because it's on the bank of a river. So it'll start pushing this way, and slowly the animal's home will slowly break apart as water starts to erode against the side, and then soon. And this is after a while, probably a couple years, it will make a small dent in the river. It will make a small curve. And then soon, as sediments from this side are dropping down, they'll hit against this side. And then that'll make a curve. And then basically, over time, it will turn into this, as sediments slowly erode the sides by pushing them up. This is basically how curved rivers form. It's also about water erosion. And then, over time, as it gets too curvy, and it gets so okay, it's kind of not like that. I'm trying to draw it, but it's off the top of my head. I watched a video about it. Basically, when two currents of a river hit each other, I'm trying my best. What would happen? I'm just gonna do this quick. Is basically water will go into a different current, and this will create an oxbow lake. Basically, when a small part of the river detaches because the water from this new part of the river that bumped into the other, they'll go that way, then this way because it's quicker, and it'll turn into an oxbow lake. So that's water erosion. That's how it also makes curvy rivers. So, let's go to the next one. I just wanted to show, I found a good video not a video, a picture of a gully. Just if you're wondering what it looks like. There's the rock dam to check gully erosion, the plantation forestry, the left side of the gully, and the gully floor. So, through time, gullies. Oh, this is in Kanska. I don't know. Basically, what happened here is probably sheet erosion. If there is a slope, water came down. There is something about sheet erosion in here, if I'm correct. No. Basically, water came down, and it slowly eroded, the size. I'm gonna have to check, but I think most of you know what happened. Sheet erosion causes gully to be formed. I don't really remember. I don't have time to check right now, so we'll just move on to the next photo. Glaciers. Basically, this could have been like the last ice age when the glacier hit. So this looks normal, and then we had the glacier. Just take your time to look at this photo. Maybe pause the video here. Take a good time to looking at this. It's probably in a different language. I just found this. Oh no, this is English. Okay, it's English. I don't know what these words are. They're highly scientific words, I know that. So the ice are right here, and basically they're carving, basically a glacier had been carving its way through this area, right here, had carved itself through the mountains, and then has also carved this area, and then today, looks like it created a small pond area, probably a river too. The hanging valley, basically you can see the glacier, what it did. This happened last time. I'm not sure what that is. Oh yeah, it's a lot brighter because of someone messed with the lighting, the brightness. Here's the next photo. Saltification. Wind erosion. When wind comes, basically on a small area on the ground, it will start basically breaking up rocks, and as the wind keeps eroding the top of it, it'll start sending particles up in the air. Or it can send smaller particles down this way, or this thing will, as it gets pushed by wind, gets slowly creep. And yeah, this is wind. Actually, this is saltification. This is saltification. No, this is not even erosion. Where did I find this? I found it in erosion. No, I remember that. Okay, snowball Earth. The most biggest erosion thing you can tell by snowball Earth. Snowball Earth was a devastating period where the Earth actually, just imagine our entire Earth just turning to something that looks like a snowball. That's what happened. Basically, what happened is, there was a lot of volcanic activity, and these mixed with the clouds, and that there's also other reasons why it happened. Probably. So yeah, basically, the carbon dioxide got into the clouds and made it acid rain. This is the main reason why it happened. And acid rain poured on the planet as more volcanoes kept spraying out gas. And back then, they didn't have dirt. It was just rock. So the rocks absorbed the acid rain, not making it able to dissolve back into carbon dioxide, so warming the planet. Basically absorbed almost all of the world's carbon dioxide. So basically then, suddenly, the entire Earth got dominated by two glaciers from the north and south. They're actually the polar caps, and they moved towards the equator and shut the entire planet in the Ice Age. And the next episode will explain more about Snowball Earth. So, bye guys. See you in the next episode.